Hello learners, today we are learning about simple titration. So we have this question: 5.3 gram of sodium carbonate contains 250 milliliter of water and 0.2 molar of hydrochloric acid. This compound carbonate, we don't know X, we have X molecules of water. So the procedure says fill the burette with hydrochloric acid, then place, using a pipette, place 25 centimeter of sodium carbonate in a clean conical flask. Then you fill the table. When you fill the table, the first question is asking, calculate the average volume of hydrochloric acid used. To calculate the average volume of hydrochloric acid used, without wasting any time, from on 1, this is what you do. You add these 3. Then you divide by 3. 18.8 plus 18.8 plus 18.8. Then you divide by 3. First you add it, you get 56.4. Then divide by 3, you'll get 18.8 centimeter cubic of HCl. So this is the volume of HCl used. This is the volume of HCl used. If you ask the number of moles of HCl used, you use this volume. Roman 2, they are asking the concentration of sodium carbonate in gram per liter. So in sodium carbonate, we have the mass and we have the total volume. So this is what you said, 5.3 gram, which is the mass, is equal to total volume, which is 250 ml. What about 1000 ml? Where are you getting this 1000? This is where you are, this 1000 you are getting it from concentration, because concentration times volume is equal to 1000. Then you cross multiply. 5.3 gram, 5.35 gram multiplied by 1000 ml all over 250 ml over 250 ml. ml and ml they cancel. When you divide, you'll get 21.4 gram per liter. So that's the concentration of sodium, carbonate in gram per liter. We have other questions. Question Roman 3. This is Roman 2. Question Roman 3 in our next page. This one we have done it. Concentration of sodium in gram per liter. We have done it. Question Roman 3, it's this one. The number of moles of hydrochloric acid used. To get the number of moles of hydrochloric acid used, Roman 3. Hydrochloric acid, we have the molarity of hydrochloric acid. The molarity is 0.2 molar. We also have the volume of hydrochloric acid used, 18.8. Then to get that, then you will say 0.2. Therefore 0.2 molar, which is the molarity of hydrochloric acid, is equal to 1000 centimeter cubic. What about 18.8? What about 18.8, which is the volume of hydrochloric acid used? Average volume 18.8 centimeter cubic. How much will it be equal to? Because they are asking the number of moles used. To get the number of moles used, molarity is equal to 1000. Volume used, which is 18.8, the average volume is equal to how much? 0.2 moles multiplied by 18.8 all over 1000. When you multiply, you will get 0.0. You will get 0.00376. 0.00376 moles of which? Of HCl. This is the number of moles of HCl used. So the next question is asking, which is Roman 4. This is Roman 4. Roman 4 is asking the number of moles of sodium carbonate used. To calculate the number of moles of sodium carbonate used, we need larger space. We use equation. Here we have the number of moles of the acid used. To get the number of moles of the carbonate, we react the two equations. We say sodium carbonate aqueous plus hydrochloric acid aqueous. We will get sodium chloride, a salt, aqueous, plus carbon dioxide aqueous, plus water, liquid. Okay, to balance the equation, let us use a different red pen. a different pen at the red pen. We balance the equation. Sodium 2, sodium we don't have 2 here. We have 1 sodium. We balance 2. Okay, sodium balance. Chlorine 2 here, chlorine 1 here. Then we balance here also. Hydrogen 2, hydrogen 2 here, balance. Oxygen 2 here, plus 1 here, 3 oxygen this side, and here also 3 oxygen. Carbon 1 here, carbon 1 here, balance. So the mole ratio of the reaction of the reactant is 1 of sodium carbonate to 2 of hydrochloric acid. So here we have the number of moles of the hydrochloric acid we have. The number of moles of hydrochloric acid here is 0.00376. So, and we have its mole ratio here. So 2 mole ratio equivalent to 0.00376 moles of hydrochloric acid. What about 1 mole ratio here? What about 1 mole ratio? Here X, then cross multiplication. So here you will get 1 multiplied by 0.00376 all over 2. Then therefore you will get 0.00188 moles of what? Of sodium carbonate. So this is the number of moles of sodium carbonate. This is the number of moles of sodium carbonate. 0.00188 moles of sodium carbonate you get through equation. So the next question is which is Roman 5. Question Roman 5, the concentration of sodium carbonate in moles per liter. Concentration in moles per liter means molarity. Here we have the number of moles of the carbonate used. We also have the volume of the carbonate used, 25. They are equal. So this is what we do. Roman 5, this is what we do. 25 centimeter cubic, which is the volume of the carbonate used, is equal to the number of moles used, which is 0.00188 moles of the carbonate used. Then concentration in moles per liter is equal to molarity. So molarity in terms of volume always equal to 1000. So 1000 centimeter cubic, how much will it be equal to? So you do cross multiply. So 1000 centimeter cubic multiplied by 0.00188 all over 25. All over 25, yes. Anything you multiply, x is 25. Then you get here 0.07, if I'm not wrong, 0.0752, yes, 0.0752 molar of which solution? Sodium carbonate. Sodium carbonate. So that's the molarity of sodium carbonate. So we have another question. Question Roman 6. Question Roman 6 is asking the concentration we have gotten. Question Roman 6 is this one. Roman 6. It's asking the relative formula mass of the sodium carbonate and the value of X in the water moles, where sodium is 23, carbon 12, oxygen 16. Okay, to get that, we get first RFM, or molar mass. Molar mass can be obtained molarity using this formula. Molarity is equal to concentration in gram per liter over RFM. So concentration in gram per liter, we have it already. We have obtained concentration gram per liter in our first part. It's here 21.4 gram. And also we have our molarity here. Our molarity is this one that we have obtained right now, sodium carbonate. Therefore, instead of molarity here, we will put 0.0752 is equal to concentration gram per liter, which was 21.4 gram. 21.4 gram all over RFM, or molar mass, that you don't know. So this one, there is one hidden here. You cross multiply. You cross multiply. RFM multiplied by this one. This is what you get. 0.0752 multiplied by RFM is equal to 1 times 21. 1 times 21.4. 1 times 21.4. 1 times 21.4. then you divide both sides by 0.0752, 0.0752, then here you divide 0.0752. So therefore this one they cancel. RFM of sodium carbonate is equal to, when you divide this one by using calculator, you get 285. So this is the value of RFM, but we need to get the value of X. To get the value of X, let me open a new page. To get the value of X, this is what you do. We have sodium carbonate dot X molecules of water. That's the compound that we have. Is equal to the RFM, which was 285. So sodium is 23 according to the bracket. 23 times 2. We have 2 sodium here. Plus carbon was 12, only 1 carbon. Plus oxygen, 1 oxygen is 16 times 3. Plus X. This X, then we open bracket. X is multiply anything from water. Water, hydrogen is 1 times 2. Plus oxygen 16, 1 oxygen is equal to 285. Then when you multiply these 2, you get 46. Plus, that means you are saying 23 times 2, 46. Plus 12. Plus 16 times 3, which is 48. Plus 1 times 2 is 2, plus 16, 18. 18 times X, 18X is equal to 285. Then now here you add all this. You add all this. 46 plus 12 plus 48, you'll get 106. Plus 18X is equal to 285. When you are here, you collect like times. 286 you bring here, or you transfer this one to the other side. You'll say 18X is equal to 285 minus 106. Because when you transfer this 106 here, it becomes minus according to mathematics. 18X therefore is equal to, when you subtract these 2, you will get this value. Subtract it. You subtract it 1. You subtract it 1. You subtract 285 minus 106. You will get 179. You will get 179. You divide by 18. You divide by 18 here. Then therefore X is equal to, value of X is equal to, you'll get 9.99, meaning that X is equal to 10. So therefore that compound is heptahydrate. Therefore that compound is, it was 9.99. Therefore in that compound, and this 9.99 you round it, then you get 10. So the compound is sodium carbonate decahydrate. Deca, not heptahydrate. Decahydrate. Deca means 10 molecules of water. So that's how you do, learners. Please, I want you to be serious with this question, because this question always they bring in the exam. The reason as to why I was making faster my question, because of time. The screenshot that I'm using, the screen recorder that I'm using is has a limited time. So that's why I was making faster. I was rushing it. I don't want the time to elapse so that my recording stops. So that's why I was rushing faster, and I cannot repeat it because I have only 1 minute for the recording. It's stopping. So please revise and repeat. If you have any question, you can ask me in the description below. You can write in the comment section if you have any further question. Thank you for listening me, and I wish you will take advantage of this course that I'm giving you through online. Thank you.